Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 10, Lesson 7 on the sectors of circles. All right, so this is kind of a fun topic. I love this and it's not too bad, right? Especially if you've been with us and you've taken a look at the area formula of a circle and the circumference formula of a circle, then sectors of circles will be pretty easy to deal with. So let's get into them right now. Make sure to have your calculators handy. We're definitely going to be getting into some obnoxious calculations, but they should be relatively easy as long as you've got the technology. So let's talk about what a sector of a circle is. Now, a portion of a circle that is bounded by two radii and an arc of the circle is known as a sector of a circle. Sectors are very important in design, engineering, mathematics, and pretty much pizza, since a slice of a circular pizza is almost always a sector. In this lesson, we will learn how to find the area and the arc length of a sector. So let's kind of get into it and look at an easy exercise. Exercise number 1. Circle O shown has a radius of 12 inches. A sector has been defined by two radii, OA and OB, and has a central angle of 60 degrees. Letter A. In geometry, this is known as the minor sector created by these two radii. Why do you think it's called minor? All right, so pause the video now and, speculate. Why would I call this the minor sector created by that particular set of radii? Well, because, in this circle, there are really two sections of the circle that are bounded by those two radii. There's the one in blue, which is the minor sector, and there's everything else, which would be called the major sector. Now, why is that the minor sector and that the major sector? Because that is less than half of a circle, right? And that's it, right? So it is because it is less than half the circle. And I'm going to add something else. The central angle is less than 180 degrees. All right? So every time we take a circle and we draw two radii, it's going to enclose two portions. One that's going to probably look more or less like a slice of pizza, and then the other one. Now, by the way, a semicircle, half a circle, is definitely a sector of a circle, right? It wouldn't, I guess, be either minor or major. It would just be called a semicircle, but you get the idea. Now, before we move on, let me just give you the thrust of the whole lesson. What we want to do today is we want to figure out how to calculate the area of the sector, whether it's a minor or a major, doesn't really matter. And we want to be able to figure out literally the length of that arc. So, we always talked about the measure of an arc being in terms of degrees. Now we're going to be talking about, well, is that 3 inches long? Is it 5 centimeters long? How long is that arc? That's it. So let's get into that a little bit. Letter B. Determine the circumference and the area of circle O. Express your answers in terms of pi, and to the nearest hundredth, include proper units. All right, this should be easy peasy, right? Because we've been spending the last 3 lessons or so talking about areas and circumferences of circles. Don't worry about the sector at all. I just want to know the area of circle O and the circumference of circle O, both in terms of pi and to the nearest hundredth with units. Pause the video now and go ahead and do that. All right, well, let's first get them in terms of pi. So we know that the circumference formula, is pi times the diameter of the circle. The diameter of this circle is 24 inches, so the circumference is 24 times pi, and I'll put down inches. We know that the area of a circle is pi times its radius squared. In this case, that's going to be pi times 12 squared. 12 squared is 144. So the area of the circle in terms of pi is 144 pi square inches. All right. Now, we'll just take out the calculator in a moment and come up with these two in terms of to the nearest hundredth. But I just want to point out, these should be easy. You should be able to have done these a couple years ago. Now, let's go ahead and just come up with what they're equal to in terms of decimals. 24 pi easy. That's going to be 75.40. All right, there's our circumference and our area, which will be 144 pi is 452.39. And again, square inches. All right, easy enough. Now, letter C. Time to work with some fractions. What portion or fraction of the circle's area and circumference are contained in the shaded sector? Explain. So I don't want to know what the area is. I don't want to know what the arc length is. I just want to know what fraction. Is it 2/3? Is it 1/2? Is it 1/5? What fraction of the circle's area and the circumference, and it's going to be the same fraction for both, is contained in this sector? Pause the video now and see if you can figure this out, and it is a relatively nice fraction. Well, it's going to be 1/6, all right? In fact, here, let's visualize it, right? We can put 6 equal slices that are like that within this circle, and therefore the area of that sector must be 1/6 of the entire area, and the circumference, or sorry, the arc length from A to B must be 1/6 of the total circumference. Now, why is it 1/6? Well, it's 1/6 because the total angle is 360 degrees, and the central angle that we have is 60 degrees, and 60 out of 360 is 1/6. That's it. So now, the thrust of the entire lesson, letter D. Using C, determine the length of AB, of arc AB, and the area of sector AOB in terms of pi and to the nearest hundredth. Well, again, I really hope you understand fractions enough that if this thing represents 1/6 of the entire circle, then if I want the arc length, then all I'm going to do is do 1/6 of the entire circumference, right, which is 24 pi. Okay, and of course 1/6 of 24 is 4, so the arc length is 4 pi inches, and we'll figure out what that is in just a second in terms of to the nearest hundredth, but let's get the area of the sector is going to be 1/6 of the entire area. The entire area was 144 pi. Here I might have to do a little bit more work and and bring this up, and I'll just do 144 divided by 6, and that's 24. So that's 24 pi, okay? And that will be square inches. And again, we'll get the decimals in a second, but I just want to kind of summarize here, right? So every single time we have a sector represents a particular fraction of the overall circle. The fraction's easy to figure out. You just take whatever the central angle is and divide it by 360. So like literally our fraction is 60 3/60ths, which is kind of hard to think about, but thankfully this thing, right, reduces down to a nice fraction, 1/6. We wouldn't have even have to reduce it though. We could have literally used this fraction right here, and we still would have gotten those answers. Now we still want these things in terms of decimals to the nearest hundredth. So real quick, that's easy enough. If I just do 4 pi, right, that's going to be 12.57 inches. Let me circle those, and 24 pi, and that will be 75.40 square inches. All right. And really, that is basically the whole lesson. Now, in this particular problem, we had a sector that was really nice. And if you're a little confused by this, I want you to think about how natural this would have been had we had a semicircle, in which case the fraction would have been 1/2, or even if we had had a quarter circle, in which case the fraction would have been 1/4, right? You even dealt with those two scenarios on the homework that was on the circumference of a circle and on the homework with the area of a circle. You dealt with both semicircles and quarter circles, and you were probably more than happy to put a 1/2 in there and a 1/4 in there, Here, we just have to figure out what the fraction is. And in this case, it was 1/6 because we had 60 out of 360 degrees. But let's work with a little bit of a messier one. All right. Now, the key to all sector work is that the area of the sector and the length of the arc of the sector are proportional, nice word there, to the central angle created by the two radii. So let's look at a more tricky scenario in exercise number 2. A patio in the shape of a circular sector has a radius of 20 feet and a central angle of 110 degrees as shown. Find the area of the sector to the nearest square foot. Show the work that leads to your answer. All right, so let's talk about how you generally can do with one of these problems without figuring out that 1/6 up front. All right, so here's the thing, right? Whenever I have a sector, the first thing I always consider is what would be the area, in this case, because that's what I'm looking for, of the entire circle. All right, so the area of the whole circle, right? The area of the whole circle is going to be pi r squared, and that's going to be pi times 20 squared, and that's going to be 400 pi. All right, and it's going to be feet squared, but I'm not going to put that down right now. So the area of the entire circle would be 400 pi square feet. Now, I can always do something like this. The area of the sector divided by the area of the whole circle will be equal to the angle of the sector divided by the whole angle. All right, this is what it means to say that the area and the arc length are proportional to the central angle, right? So the fraction, right, of the angle to the whole angle is going to be the same as the fraction of the area of the sector to the area whole, and if we needed the arc length, it would be the arc length divided by the circumference. Now we know the whole, right? The whole is 400 pi. So I can say that the area of the sector divided by 400 pi is equal to 110 divided by 360. And of course, I could solve this by cross multiplying, and that would be fine, but it's actually a lot easier to just multiply both sides by 400 pi, right? Those cancel, and my red pen comes out for a visit. Let's do that. And now I've got my area. Now again, keep in mind, what we're really saying is that the area of the sector is the fraction of the whole circle it takes up times the area of the whole circle, right? So for me, I would just write this down immediately. Well, the fraction I have is 110 3/60ths, right? But, you know, 4 out of 3 people get confused by fractions, so it's maybe helpful to set up the proportion. I snuck in a little math joke there. It's helpful to set up the proportion, right? And then do the kind of cross multiplying or what have you. Now let's just make sure how we want our final answer. It says find the area of the sector to the nearest square foot. I don't need it in terms of pi. And what's great about that is that that means I can now bring my calculator out. I can simply do this. Let me just kind of clear up my screen. I can say, well, I'm going to do this fraction, 110 over, whoa, that didn't work. Come on. There it is. 110 over 360, that's the fraction of my circle taken up by the sector, times 400 pi. Don't forget the pi. Never forget the pi. And we get a final answer of 384 square feet. All right, so easy. It's just what's called proportional reasoning, right? You've got the area of the whole circle or the whole circumference, right? The distance around the whole circle. You've got an angle that tells you how much of the circle, right, is being taken up, right? That's 110 out of 360. And then we just take that fraction and we multiply it by the whole area or the whole circumference to get the area or the arc length of our sector. It's that easy. So let's keep going. Let's keep working with it. Now, if you can solve a proportion, and I know you can determine the arc length or area involving a sector. Let's take a look at exercise number 3. A garden has the shape of a circular sector. Its straight sides measure 50 feet each, and its central angle is 132 degrees as shown. The garden needs to be surrounded by fencing on all sides. Fencing comes in rolls that are 25 feet long. How many rolls of fencing will be needed? show how you arrived at your answer. All right. Well, I think probably it's a pretty easy idea here. We need to figure out the distance all the way around this sector, including the 2 radii. And then we need to divide that by 25 feet to figure out how many rolls of fencing we need. I'd like you to pause the video right now and see what you can do. All right. Well, again, this, right, is just part of a circle. All right. The whole circle would look something like that, right? So the first thing I'd like to do is think about the circumference of the whole circle, right? So the circumference of the whole circle, right, which is pi times its diameter, which would be 100 pi, yes? Right, 100 pi because the radius is 50, the diameter is 100. Awesome. But how much of that do I get along this curved section? Well, again, it is quite okay to do this kind of business. The arc length divided by the circumference is equal 132 degrees divided by 360 degrees. That's great. You know, if you feel comfortable with this, awesome, right? And then we know that the circumference is 100 pi, so we can multiply by 100 pi on both sides, right? And again, all we're doing is taking the fraction of the circle that the sector represents and multiplying it by whatever the whole is, whether it's the whole area or the whole circumference, regardless, right? Now this number, whatever it is, and I'm just going to hold off until the end, that is the length of this, right? So that's that length. Let me go back to my pen, right? So we need to take that length and we need to add it to 50 and another 50. In other words, we need to add it to 100. So let's figure out what that is. That I wouldn't mind having in terms of a decimal. So I'm going to do it all at once. I'm going to have my 132 divided by 360 times 100 pi, right? That's the arc curve, the arc length, plus 50, plus another 50. And so I have, right, a length, not an arc length, but a total length maybe. Let me put down the word total. A total length of 50 plus 50 plus that, which is going to be 215 point, let's say, 19 feet. All right, that is my total length. And again, it's quite all right to figure this out, get it in terms of a decimal, then add that to the 250s, and then get this. I just kind of like doing it all at once if I can. Okay, now, ultimately though, right, the question was how many rolls of fencing will be needed? Right? The question wasn't how long the outside was, it was how many rolls of fencing would be needed. Now, obviously, what I can do is I can take this thing, and I can take that total length, 215.19, and I can divide it by 25 feet per roll. So I'm going to just divide this by 25. Whoops. 25. I still can't seem to get that 2 in there. 2. Oh, that's why. Okay. Really? This is fun. Oh, okay. There we go. Divided by 25. Fun with the board. Okay, this is 8.607, right? Now, keep in mind what that represents. That represents how many rolls of fencing I need. But the assumption is, of course, I can't go to the Home Depot and ask for 8.607 rolls of fencing. I'm going to need 9 rolls of fencing. Even if that was barely over 8, the answer would still be 9 rolls of fencing. Okay, cool. Now, what we've now seen is given, an angle and given the radii, we can figure out the area, right? And we can figure out the arc length of the sector. But there's one more issue, right? And that's figuring out the angle itself, finding the central angle. This proportional relationship can also be used to solve for the central angle if information is known about the area or arc length of the sector. Okay, so let's take a look at exercise number 4. A sector of a circle whose radius is 6 centimeters has an area equal to 4 pi square centimeters. Determine the central angle of the sector to the nearest degree. All right, well, what I'd like you to do is play around with this idea for a little bit, and then let's see what we get. All right, well, just like before, where I'd like to start is by thinking about the whole circle. Not just part of it, but the whole thing. And there is just my terrible picture of a circle. That's okay, right? So the whole area, the area of the whole circle, would be equal to pi times 6 squared, or 36 pi. All right, so that's the area of the whole circle, right? So now I could say, well, the area of the sector, which is 4 pi, divided by the whole area, 36 pi, is equal to the angle, maybe I'll call that x, divided by 360 degrees. All right, and now it's exactly the same idea. The difference is, right, the fraction of the circle that's taken up now is given to me by the fractional or the ratio of the two areas instead of the ratio of the two angles, right? But it's still the same idea. To solve for that central angle, I'll just multiply both sides by 360 degrees. All right, those will cancel. And let's see what my calculator tells me. It's actually quite easy, right? Because I can put all of that in. There's nothing wrong with putting it in exactly the way it looks. If I have my fraction and I say 4 pi in the numerator, 36 pi in the denominator, times 360 degrees, I find that my angle is equal to 40 degrees. It's that easy. So the moral of the story is, right, if you are given, right, the area, or the radius or whatever and the central angle, you should be able to calculate the area or the arc length of the sector. And the flip side of it is, right, if you're given the area or the arc length of the sector, right, you should be able to then calculate the central angle. All right. So let's take a look at one last problem. Maybe our most complicated one, exercise number 5. A horse is attached to a rope that's 8 feet long. When the rope is extended, the horse can walk through a maximum distance of 30 feet as shown. What angle can the horse walk about round to the nearest degree? Awesome. Well, this is very similar to the last problem. We want to figure out the angle. And side note, the picture is somewhat drawn to scale. So your answer here is going to be larger than 180 degrees because we are looking now for a reflex angle. We are looking for that angle. All right. See if you can figure out what that angle is to the nearest degree. Well, just like before, I'm going to start by figuring out the whole circumference, right? So my entire circumference of the whole circle, right, if I kind of drew that in, right, that circumference would be pi times the diameter. Since the radius is 8 feet, the diameter is 16 feet. I cannot get that equal sign there. Still can't. Anyway, it's 16 pi. All right, so that's the entire circumference. All right, now what I can do is I can say my arc length, which is 30 feet, divided by my circumference, which is 16 pi feet, is equal to my angle, which I'll call maybe x degrees, right, divided by 360 degrees. That's it, right? My arc length divided by my circumference is equal to my angle divided by 360 degrees. Just like before, I'm going to multiply both sides by 360 degrees. This is where it's very, very handy to have your calculator because this thing is not a very nice answer. Anyway, let's do it. I'm going to go back, grab my fraction. I've got 30 divided by 16 pi times 360 degrees. And I'll find that my angle to the nearest degree is 215 degrees. It's a 215 degree angle. All right, let me write that up. Okay. Hopefully you got the 215 as well. Let's take a look at letter B. If the horse can access all the area within the sector to graze, how much grazing area did the horse have to the nearest square foot? Right? So now we want to know the area of this sector, but we have an additional piece of information at this point. Right at this point, we know that that is 215 degrees, right? And we were able to figure that out from the first part of the problem because we knew what that distance was. So now, why don't you go ahead and figure out what that area is to the nearest square foot? Well, again, let's talk about the total area, right? The area total, right, pi r squared is going to be pi times 8 squared, and the total area is going to be 64 pi, right? So the area of the sector divided by the total area is going to be that 215 degrees divided by 360 degrees, right? We know that our area total, maybe I'll go over here, my area total is 64 pi, right, equals 215 over 360, which means the area of my sector is 215 divided by 360 times 64 pi. And let's figure out the area of that sector. All right. Again, fraction 215 divided by 360 times 64 pi equals 120 square feet. All right, and that's it. Okay, so kind of a nice problem, right? Because in the first part of the problem, we use the arc length to figure out the angle, the central angle of the sector. And this is one of the only situations we dealt with where we were working with a major sector versus a minor sector. And then, because we now know the angle of the sector, we can now figure out the area of the sector by also doing that proportional reasoning. All right, let's wrap this up. So really today, what we did was we extended our ability to work with circles by working with portions of circles, specifically portions of circles that are bounded by 2 radii and the arc length that they intercept, okay? And everything that we do with sectors of circles, whether we're finding their area or the length along their arc, all comes down to proportional reasoning. It's all about how that central angle of the sector compares to 360 degrees, right? And again, this is relatively natural, right? You've worked before with 180 degree central angles giving you a semicircle and 90 degree central angles giving you a quarter circle. Here, we're now saying we could make the angle anything we want, right? And that angle divided by 360 is whatever fraction of the circle we have. All right, well, sectors of circles probably won't be too important as we move forward in this unit because now we're going to move up to 3-dimensional objects, but they will come back, especially in Algebra 2, quite a bit. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.